like total of 9 experiments. I cannot state everything. I will just briefly say 7 of them. I will introduce the research question and how the what the test experiments are doing, and introduce the dataset name, show the figure, baseline, and interpretation here. Does adding metadata to the input improves the model performance? In order to answer that research question, they test model performance with or without adding metadata to the input. So on the movie lens data, is real world, is 20 million interaction. It's very large. They try to test adding metadata. This is adding the input feature decoding, and this is adding user features and the feedback encoding. And the metric is perplexity. The lower the better. And as you can see here, the 2 lines that improve the performance in perplexity from its baseline. So from the MLP is improving, and from the binary RNN, HRNN-meta is improving its perplexity. So yes, metadata is useful. Long-term dependencies. Does HRNN leaves vanishing gradients problems, and thus allowing models to have longer memories? They suggest qualitative example of a recommendation for a virtual user who watched the following movies, the 5 movies here, with the genres specified. And they see if the consistent recommendation is possible after some time passed. So the genres of this movie is usually about comedy and drama, and after the delta t, the time stamp, as time goes by, the recommendation has to be grounded to this comedy and drama, and it actually did. And they can't really show some quantitative experiments, but they claim that HRNN-meta has learned to place some weights on temporal inputs and maybe relieve long-term dependencies. And in RNN and HRNN-meta, they compare HRNN-meta itself to its baseline. So the first question is hierarchies in RNNs useful for recommendation system? They compare HRNN with time delta controls and input feature decoding. I denoted as HRNN plus here, against other baseline models, GRU and HRNN. This is the HRNN that was mentioned in related works, and POP and BPR. As you can see, the higher better, and is showing good performance, but it's slightly low. But they claim that this proposed method, it shows 10 times faster throughput computationally than the baseline. So they also introduced the feedback encoding. Is feedback encoding useful for encoding contextual info? They compare HRNN with feedback encoding against other contextual encoding methods, such as factorization, machine, and or other things. They presented the results from 2 datasets, and as you can see, when using HRNN, when actually using feedback encoding, lowers the error. The lower the better, so this is good. But when we are not using this feedback encoding, the performance is not good. So they conclude that feedback encoding is actually very useful for encoding contextual info. And for the cold start scenario experiment, they simulate cold start scenario from benchmark dataset by randomly selecting half of the all items and evaluating the recommendation performance only on that half selected items. And their baseline is called random choice, and compared to the baseline it outperforms, and proving that the HRNN-meta is very effective in cold start scenarios. The importance sampling, does IS importance sampling improve the computational efficiency? They compare the performance and throughput of the HRNN model with and or without importance sampling on various large-scale datasets. As you can see, there are several datasets that increase in scales as you go right, and the IS is the baseline, not the baseline, the proposed method that is HRNN with importance sampling. Actually, this is incorrect. HRNN-meta with importance sampling, and the density refers to HRNN-meta without importance sampling. And as you can see, this represents memories, and it shows great difference in memories as well as in the throughput, but IS is showing better results in PPL. No, actually, density is, density is showing PPL great result in PPL. So yeah, we can formally say that IS is very good and greatly improve the computational efficiency. And for the item trend corrections, does ITC improve recommendation performance and stabilize the learning when item trends are changing? They test model performance with real-world dataset that has changes in the item trends. I mean the item popularity trends, and they use this outbrain dataset. I think it is a dataset that is designed to like evaluate the trend invariance of these recommendation models. And the blue line represents our model, and the baseline is the I think is like state-of-art baseline, and the yellow line, the green line refers using HRNN-meta without ITC. So it shows great difference, and it also outperforms the baseline. So we can conclude that ITC is very effective against the trend invariance. So the conclusion: HRNN-meta solves all. I mean, it first addressed these 5 research goals and the key components of HRNN-meta that are in total 5, and as well as these 2 additional solutions, they sort of somehow related to these goals. But my review on this work is that I want to just know how to efficiently build metadata for cold start scenarios for graph neural networks, because it's really using the metadata it's remarkable. Yes, thank you for the listening, and thank you.